video, we're going to discuss entropy. Entropy is the measure of a system's ability to do useful work. So as entropy increases, the ability to do useful work decreases. So let me build up to the explanation of why this definition exists. So entropy is that mysterious S that we're talking about in the heat engine video. Entropy is going to equal heat divided by temperature. And this temperature must be in Kelvin. This is going to be in joules, so the units for entropy are joules per Kelvin. Now there are two conditions we have to meet with entropy. When we have a cyclic process, the change in entropy must be 0. So you must return to the same amount of entropy that you started with. However, entropy of the universe must always increase. This means when we deal with a cyclic process, when we deal with going from inside the engine to expelling energy at our cold source, we must expel entropy so that it returns back to its original state, but at the same time always increase the entropy of the universe as a whole. So let's talk about how we're going to do that. Alright, so we're going to have our heat engine here. So we're going to have energy coming in to QH. The engine is going to do some work. And then we're going to expel energy to the cold source. Now keep in mind, the energy is coming from here, the engine, so it's being kicked out of the engine to the cold source. This means that we're taking the amount of energy that we're calling QC from a location that's hot, the engine, we know engines should be hot, to the same amount of energy to a location that is colder. So when we look at entropy inside of the engine, and entropy outside of the engine, which entropy is bigger? Now, which entropy is bigger is a little bit counterintuitive because the QCs are the same in both instances. So we have to focus in on the temperatures, and the temperature's in the denominator. So if you're dividing by a bigger number, you get a smaller number. So this number is bigger than this one, so you're going to get a smaller entropy here. So the entropy inside the engine is less than the entropy outside of the engine. So this means we've expelled enough entropy in order to return the system back to its original thermodynamical state. But because this number is bigger than this number, you've actually increased the entropy of the universe. So this is why you always have to flow from hot to cold, because this was TH and this was TC. So you're always flowing from hot to cold in order to be able to increase the entropy of the universe while return the system back to its original thermodynamical state. And this is why you can't have a 100% efficient engine, because a certain amount of thermal energy must be expelled from the system in order to return the entropy to its original thermodynamical state. So that's sort of hidden inside of the entropy equation is heat. So there are two reasons why you need to expel heat, one for delta U and the other for delta S. And because a certain amount of the energy coming in must be expelled in order to return it back to its original thermodynamical state, not all of it can go into the engine doing work, which is why entropy is a measure of a system's ability to do useful work, because there reaches a point where you build up so much entropy and you need to expel heat to get rid of it, the system can't do any more useful work.